So, hello and welcome. I just wanted to talk to you a little bit about the project I introduced in the last video, the runway incursion add-on that I launched as an idea last time. And I also want to talk to you about something new. I wanted to try a slightly different format of video. Um, as I was working on this, I realized that I picked up quite a little bit of experience on the SimConnect and Flight Simulator 2024 development, and I was looking around and I also saw that, well, there is really not any SimConnect content around, specifically on YouTube, and no videos really to show you how things work and to explain a little bit about this. And so I figured, well, why don't give it a try? Um, so you might wonder, well, what am I looking at this screen for then? Well, what are we talking about here? Well, this is the first result of the programming I've been doing for the add-on. If you look at the distance, you can see deer. 1, 2, 3, and there's actually plenty more. So there's, yeah, just a short demo before we get into the SimConnect content to show you what I've been doing. So for the people who missed the first video, the idea is that we want to develop an add-on that will, at random, cause runway incursions, basically. So that could be animals, that could be vehicles, or anything else that we can put on a runway randomly. I started with animals because, well, yeah, it's cool. We can do a lot with that. So I hope to have some fun with that, and so far I did. So you might wonder, well, there's animals there, but they're not on the runway, and there's more than one, and what's going on? Well, once we get along in the project, I'll explain a little bit more. But for now, this is just me debugging issues. If you look down here, unfortunately, in this vehicle, I cannot turn up the brightness for some reason, but you can see all these little airplanes. These are in fact animals, which is funny because, I put an animal as a sim object, and somehow the avionics in this aircraft decide that those are aircraft. But it's very helpful in this case to troubleshoot my issues, because I tried to put them all on a runway, and you can see that the angle is off somehow. But that's for another day. Just wanted to show you a little bit about what I was doing. And this is also helpful later in what I'm trying to explain to you about the SimConnect development, what am I doing here, and how you can troubleshoot stuff. But that's for a couple of steps down the line, I guess. For now, I wanted to just make an introduction, just show you what I had so far, and then dive into the SimConnect basics. So I hope you're excited. For now, if you think this content is cool, if you want to learn a little bit more about developing for Flight Simulator 2024, specifically SimConnect, please subscribe, leave a like if you like this video. That really helps me. So that being said, let's get into it. Okay, so before we dive right into code and stuff like that, there's some basics I wanted to talk to you about to have a little bit of better of understanding of what's actually going on in the code. And even before that, some disclaimer stuff. I write my code in C#. That means we do a managed SimConnect client, which is slightly different from the C++ versions. I will talk a little bit about the differences along the way, but that probably is not going to cover all of it. But I also think the C++ examples are in the SDK, and they're very useful. They're even useful if you're going to do managed code, but it's still a little bit different, and sometimes if you're not used to it, it's hard to figure out how to do stuff in managed when you only have C++ examples. Another thing is I'm not going to teach you C Sharp, so if you don't know C Sharp, you should probably, look up some details about that. And if you have questions about that, you can always leave a comment, and I'm happy to help. But I will not dive into those things in the videos. So also, this is not a complete guide. I'm just going to share what I learned. So if I make a mistake, if there's something wrong, again, please leave a comment. That's really helpful to all of us. So yeah, with that being said, let's get into the SimConnect basics. So I have an image to share with you. This is our setup. So on the left side here we have our program, and on the right side we have Flight Simulator 2024. Now, Flight Simulator 2024, actually most flight simulators these days have a SimConnect server running, which is what allows you to actually communicate with stuff in the simulator. And Flight Simulator 2024 is no different. There's a SimConnect server right there. And in our external program, we will have a SimConnect client. And these two have to communicate with each other. They do that with inter-process communication. And it looks something like this. Basically, the client initiates the communication with the server. It sends a SimConnect open message to the server, and then it can start communicating with the server, and then in the end it will send a SimConnect close. I put some requests in here, so you can start sending a request, and then it may or may not result in the SimConnect server trying to send a response. We'll get into what cases there are a little bit more later. You may also notice that, you should notice not all requests will have a response. That's fine. And also the order of the responses is not guaranteed. So you may send a request and then send another request, and a response to the first request comes first, or maybe they come the other way around. You don't know in advance. So you should keep that in mind when designing your code. Another thing you may notice is that this arrow doesn't actually go all the way to the client. The response will actually be sent to the process. The client is just code living inside that process. And you have to actually build something to bridge that last little bit. Fortunately for us, in the managed situation, there's relatively little work. In the C++ version, it's a little bit more code that you have to write there, which is fine. This is just to give you an idea of how this works. And I'm going to show you a little bit of code and how you would get started actually building an add-on. So here's my project. Actually, it's running right now. I'll stop it for a moment and collapse these because they're not actually relevant right now. I'll actually do it like this. So I have a solution that has two projects in there. One is the runway incursion app. This is a WPF Windows application. We will not dive into that right now because actually all of the SimConnect code lives in the runway incursions sim library. One of the first things you want to do when you're going to build an add-on like this is you want to actually reference an assembly, which is microsoft.flightsimulator.simconnect, which lives in your SDK. Right? This is the managed library. This actually gives you all the types that you need to program against the Microsoft Flight Simulator 2024 SDK, or the 2020 SDK is actually really similar. It's just a different library, but most of it is the same. You may also notice this SimConnect DLL that I have here, but you actually don't really need it. You don't really need it right now, but it can be useful for deployment purposes later, but we'll get into that in a different video. So you have this reference, that's great, and then what do? Well, as you may have noticed in the image, we need to start setting a message, so that we'll look into how we send that message, and we'll also look in how the response gets delivered to us. The SimConnect open was the first message that you needed to send. I have that code sitting in the simulator class, and the simulator class has a function called initialize, and it has a function called connect. These are the functions that we're going to look into right now. Actually, before we go and send the SimConnect open, there's other stuff we need to take care of, but let's look at how the SimConnect open actually works. In the managed client, we don't have a SimConnect open, which in the C++ client you do, you just call a function. In the managed library, we just call the constructor. This actually does the SimConnect open. So that's useful to know. This is also all very well laid out in the SDK documentation, so you should probably read about the differences between the C++ and the managed versions of this. Well, there's a couple of things we need to do when we call the constructor. First of all, I'll just pull this up. It will ask for a name. This actually identifies the connection between your application and the SimConnect server. And this is very useful specifically for debugging, to have a name here. You also pass it a handle. We'll talk a little bit more about that later. And you pass it this this integer, basically, a constant. Again, talk about that a little bit later. And then there's a wait handle that you really don't need. You can pass null and a 0 for the config index. Well, again, a lot of detail there. We'll dive into that if we need to. So this is the open message. So we just send that, and then, well, we should be ready to send a message, but we're not ready to receive a message yet. As you may recall from the image, the messages coming from the SimConnect server actually go to the process. So they go to the app in this case, which is well, not very useful if we need it in this class. So what we need to do there, well, I created a class. Well, a lot of people do it this way. There's a class message handler in here, which is this class, which takes care of bridging the gap between the message coming to the process and the message actually reaching our simulator code. There's a couple of things going on here. This thing is derived from native window, which is a Windows Forms thing. And a native window in Windows has a handle, which is very useful. So we have this function create handle, which calls our base function create handle. And it actually hides the other create handle. And then it sends whatever create params it needs, an empty one, to get the handle. That's now created. And then you can use that to actually, which actually pass into the, when you send the SimConnect open message, and messages are sent to this handle. So they actually can get picked up in here. Whenever someone actually calls something on the handle, you get this window proc method being called with the message. And that message has a message ID, which is the constant that we use to pass the SimConnect open message in the constructor, which identifies that this is the SimConnect message that comes back, and you want to do something with that. If not, we just pass this to the base winproc and do nothing with it, really. So if a message comes back from the SimConnect server, it comes into this code. That's very important. And then what we do, well, I log a debug message, fine. And also there's this message received event handler that I call with a dynamic invoke, which means it's late bound. Details can be found online. And if something goes wrong, I'll log an exception, because this can happen. We don't want to do anything specific with it right away, because this can happen even under normal circumstances. For example, when the application closes or when the simulator closes unexpectedly, we might get an exception here. So we want to ignore it. But I think it's good habit to log this at least at debug level, so you know that these things happen and you can find them if something else is going wrong. So that's this class really. And there's a stop function that you can do, that you can call to release the handle that we created with create handle, and then destroy it. So the handle is released and doesn't stick around in the operating system. This is basically the code to bridge that little gap between the message coming to the process and the message actually being handled in code. So now we can actually bind to this message received event. And if I do that, if I look at where that happens, it's in the simulator class. There's this message, this event handler, which receives the message. So there's another step you have to take. So now we have the message actually, the message sent to the Windows handle has been handled, but you don't have any data yet. So you have to tell the SimConnect class to receive the message. So you call receive message, and that actually takes care of triggering the right event on the SimConnect class. So that's a little bit fast. Basically what happens is you get a message with some kind of a type, depending on what you requested. And depending on the message that you receive, an event will be triggered on the SimConnect class. So I'll show you that a little in the code. Go back to the initialize, maybe like this. You actually see that I actually attached multiple event handlers to events. The on-receive sim object data, the on-receive airport list, on-receive facility data. These are all different message types that can come in, including giving an exception. Well, how these work is a lot more detailed. That's not important, but this is basically what happens when you do the SimConnect receive message. So now that we have a basic understanding of how the messaging works for SimConnect, let's dive into what goes into a message like this, starting with something called data definition. For actually sending messages from the client to the SimConnect server, the parameters are defined per call, and you don't really have to do any of this. But in order for the responses to actually get from the server to your process correctly, you need to define how you want the response to look. So you do that by creating data definitions, and these data definitions are have to be uniquely identified within your client. So you identify them by an integer, really. So in this case, in this example, the ID is 1 right here, and you define you have to define a couple of things. First of all, you have to define what. Well, in case we'll take an example from receiving sim variables. We'll dive into an example right after this. You have to define which sim variables you would like to have, what type they are expected to have, and how you want them to be presented to you. Now, you're coming from an unmanaged SimConnect server, which has to provide data to a memory managed environment. So that takes a little bit of extra code to make sure that that goes correctly. And the order in which you actually define what you want to have is important. So that's something to note. You might also note that this string 256, if you're a C# developer, you might find this odd. Float 64 might not mean anything to you. We don't have fixed length strings in managed code, right? So it preserves a bit of memory, and you assign it a value and it ends at some point. This is actually a double, and well, we know this is an integer. So I actually map them to types in managed code right here. And we'll dive into some code to see how this works. The example I'll use is getting the player aircraft location, which I also use in the runway incursion add-in. So let's go to the code. And let's look at how this data definition is actually constructed. I do this in the method called connect. I actually call a method register location data, which does exactly that. So in this case, the call you want to use is add the data definition. And let's just pop up this. As you can see, the first thing it wants is a data definition ID, so a define ID, and it wants it to be enumerable. I think this is a good thing because you could assign just ints, but this actually makes sure they are unique. If you use data definition like this, is just a type right here. If you just add new data definitions here, you'll make sure that they are unique because, well, C# takes care of that for you. The compiler takes care of that for you. That's the first thing. And for everything you add to that definition, you obviously specify the same identifier. The second thing is they call it datum name, but in this case, this is the simvar name that we want to get from the simulator. So I want the plane latitude, plane longitude, and the aircraft AGL. Now these names come from the SDK. You can find them under simulation variables. They have a description there for every variable that is available, or at least as far as we know. And they specify a type, the units. So in this case, the plane latitude in degrees, obviously, the aircraft AGL in feet, and then there's the technical type, which is actually the data type, right? This enumerator, this enumerable comes from the SimConnect SDK, so the DLL that we referenced earlier. In this case, and these values are all in the SDK as well, we want to have float 64, which maps to a double. And then there's this value, which is the epsilon, which is how much do you want the value to change before you get an update. In our case, I want to get an update always, so I define this as 0.0 float. And then there is a final value that is the datum ID, which actually is unused in all of these calls. But these three calls make up for what data I want from the simulator, but I haven't actually specified how I want the data to be laid out as I received it. In order to do that, we do a register data define struct. We pass in the same identifier, and it accepts a type, a generic type argument. In this case, we pass it aircraft position. Now, aircraft position is a struct that I defined myself, and it's up here. There's a couple of things to note. First of all, is this attribute, the struct layout attribute, which it allows you to control how this struct is actually stored in memory. The first thing we specify is the layout kind sequential, which means properties will be laid out in the order that I put them in the code. So I'll first have the latitude, then the longitude, and then the airplane altitude ground level. Now, before I dive further into why this is, I'll go back here and actually show you this slide. Because this is how that works. So we define our properties in a certain order. So I say, okay, I want this variable, this variable, this variable, and I have this struct. Now the order of this struct, the way the properties, the sequence of the properties in this struct actually define how it looks in memory. So in this case, prop A is a string, or it's string 256 according to the simulator. And you can see this block down here where I said it is a simvar A. So the value of this variable ends up in memory over here. So we actually define exactly in what order and in what structure our data is written into memory. Similarly, this property B, which is actually the value of simvar B, it follows that value, and it's obviously a little bit smaller because it was a double. And then for simvar C, it's even smaller because it's an int. As you can see, it's important that this structure is correct, because otherwise you'll get memory exceptions. If you go back to the code, that is what we mean with layout kind sequential. Lay the memory out in the order I give right here for these types. We also define the character set, which is important because you want to know what makes up a character in a string, because it makes a difference when you lay out your data in memory. In this case, we specify ANSI, which means we have well, the normal UTF-8 or 8-bit characters. And then pack actually, as it says, it controls the alignment. So that's basically what we say with this attribute down here. Important, right? Some readers may also see that we have this struct up here, which is actually something I want to get into right away. Although we do not use it in the aircraft position, this is a pitfall that I've fallen into. I think maybe other people have fallen into. If you have a string value, you actually have to define this Marshall as attribute on that string. You have to define it that it is an unmanaged bival string, which is what you need when you talk to unmanaged code. And you have to define, because you use this type, you have to define a size. In this case, 256 bytes. Because you have to do this for every string, this is a trick that not only I, but other developers use. You create a struct called, well, in my case, simvar string. You can even have a debugger display. This is just for convenience. You don't really need it to technically make this work. But then you can use simvar string as a field in a struct, and it automatically assigns this in memory. So you then don't have to worry about setting this Marshall as attribute on every string. But you get a simvar string field that has a value that you can access. This prevents another memory error that you might occur, that you might run into if you don't do this. Just wanted to point that out. So, back to where we found this struct. Right here. We have registered the data defined struct. And then after we have registered this this structure, and we defined the data definition and then registered the struct as the response, basically, we can then request data. In this case, this is the data on a sim object, so we do request data on sim object. We pass it a request ID. Again, This is similar to the data definitions. You want your request IDs to be unique within your application as well. And we'll find out why in a bit. So that's what you do. You pass in a request ID. It's another enum, so it's just the same as with data definition. You pass in what data definition you want, which will be how, which will make SimConnect know how to structure your data and what data you're actually requesting. You pass in an object ID. In this case, 0 is reserved for player, so this will always give the player object. If you have objects of your own, or you have simulated objects that you get by requesting data in another way, then you can pass the ID here to get data on that object. Then there is this SimConnect period. So the period, this is how long it will take for updates to pass. So this passes updates every 1 second. And then there is a well, the SimConnect data request flags will be usually you just pass default. There's origin, interval, and limit, which we will not go into right now. So this is how you request data on a sim object. In this case, the player aircraft. In reply to that, we obviously get a message through the message handler, and the message handler will find out that this message is a user SimConnect message, which will trigger the event, which will end up in SimConnect. I have to find it. Here it is, message handler, message received, which will call receive message on SimConnect instance. And this will trigger events on the SimConnect instance that we have right here, which we defined in the initializer, as we saw earlier in the video. In this case, we called for sim object data. So it will trigger either on receive sim object data or on receive exception. So this is if something's wrong. I can show you quickly what I do. I just log a warning with the exception. This is an int, so it's not very informative, but at least it gives you something to look for. I'll also show you in a bit how you might go about troubleshooting further. But this is the event we expect, right? If everything is okay, we get the on receive sim object data event. And it has a sender. This is the SimConnect instance. And it has a data, which is an object of type SimConnect receive sim object data. This, I can peek the definition on this, just to show you. It has a couple of things, like a request ID, so you actually can check what request was sent. An object ID, which is, in this case, a 0, because that's what we requested, the player aircraft. The define ID is the data definition. The flags you provided, some other properties. And this is the most important one. You also get DW data. This actually contains the data you requested. So if we close this, we can actually see how I handle this particular event. I check for request ID, and if the request ID matches the aircraft position request that I made earlier, then I will do something. Note that I have to cast this to a uint, an unsigned int, because by default in C#, this is an enum type, and this is a unsigned int. So you have to cast this, and it will work fine. If that's the case, I will call the method read aircraft position as my way of handling the data for this particular request. Let's step into that. Note that we still pass the same data object in here. from the SDK, I know if I do this call, I only get one object in the data array. So I know I have one object. I can just assume that this is correct. And I can also just cast it to the struct that I passed to the register function earlier and know that that will work. That's all because the way we laid out this struct. And in this case, I'll translate this particular struct into a object. In this case, a geolocation class that I defined, which has longitude, latitude, and altitude above ground. And I just pass in the values from my struct. You can obviously do other things if that's what you want to do, but this is how I like to handle my my events, my data coming in. And I trigger an event, do aircraft position changed, which will trigger an event on my simulator class, and then from there on I can handle this event in the rest of my application. So to summarize, before we can send data to SimConnect, we obviously have to call this constructor, which sends the SimConnect open. We'll have to manage these events, right? So depending on what type of call we make to SimConnect, we get a different event. These events actually arrive at this message handler class that we defined earlier. So this thing right here, which then triggers an event, which then leads to us calling SimConnect receive message right here. Or actually that's an event handler as well. And then we can actually define what data we want and what type we want it, and then define in what structure we would like to have it in memory by calling register define struct. And eventually we can call request data on SimObject to actually get the data out, which will then trigger the event, which we then have this data object contain our data in data.data or DW data to be completely correct. Right here. So that's how you do basic SimConnect communication. Obviously, we haven't written any data to the simulator yet. You can do that as well. And there's also other types of data that actually require different approaches, slightly different approaches from what I just showed you. But this gives you an idea of how it works, the basics of how you can get something like this to work. So for this video, I think that's where I want to leave things. In the next video, I'll probably dive into one or two things more in depth. Until then, please, if you have any questions, leave a comment. If you like this video, please leave a like. If you want to see more, subscribe to the channel. And I'll see you in the next one.